Okay, hi everyone again. We are continuing with the sea ocean spreading, the spreading of ocean bottom. In 1950s, technology was developed that allowed scientists to map the ocean floor. Long, deep trenches and mid-ocean ridges or mountains were discovered. These discoveries supported Wagner's theory of continental drift. So, you remember we talked about Alfred Wagner suggesting Pangea and continental drift, but there was no proof. Right then, in 1950s, technology started developing, and hence Alfred Wagner's theory of continental drift was valid theory at that point because people or scientists could figure out that there were trenches, there were mid-oceanic ridges, mountains inside the ocean. Then it was a valid theory, it became a valid theory. American geologist Harry Hess proposed that these ridges form when magma or molten rock pushes up through Earth's crust. So when magma or molten rock pushes up to the Earth's crust are when you find the ridges. Okay, the magma cools and forms a new crust that creates a ridge. Another scientist, Robert Dis Dice, named his process, excuse me, seafloor spreading. Hess also proposed that since the size of the Earth remains the same, the crust may be recycled under mountains and along trenches of the ocean floor. So since the size of the Earth is not increasing or decreasing, he suggested that the crust is always getting recycled. So that is the reason that the Earth is always having the same size. Proof of continental drift. As Earth's plates move, magma rises to fill the space. So that is quite understandable. So when the Earth's plates are moving, magma rises to fill the space. And when a liquid is heated, particles that make up the liquid moves faster and spreads apart. Hot liquids are less dense than cooler liquids and floats on the top. So that is also, which is understandable concept, right? As liquids cool, however, it becomes denser. So whenever liquid cools, it becomes denser and sinks at the bottom. So this pattern continues. It's a circular pattern. The process responsible for this is nothing but the convection currents. Remember, we learned in sixth grade, we learned conduction, convection, and radiation. So convection currents are currents that keep moving from high to low, and keeps going till it becomes stable. Remember? So that is what convection currents are. Convection is only one of the processes involved in the plate movement. Now, convection currents are only one of the processes. Scientists also believe that gravity plays a major role in the movement of tectonic plates. So the two things that plays major role in the movement of tectonic plates, A, it is convection currents, B, it is gravity. Okay, so that's something which you have to understand and remember that. So far, I think everybody is clear. Since the plates are slightly cooler and denser than the layer of the mantle below them, they tend to slide down towards the trenches and penetrate the mantle. So when it becomes cooler and denser, they slice to go down and then it penetrates to the mantle. In 1960s, scientists found more evidence to support the concept of seafloor spreading. Scientists studying the rock near the mid-oceanic ridge noticed a strange pattern. In some areas, the magnetism of the rock pointed north. In some other areas, it pointed south. These areas form patterns that run parallel to the mid-oceanic ridge and are the same on both sides of it. Earth's magnetism flips about once every half million years. So the magnetism of the Earth flips every 1/2 million year. You guys will learn about this in 8th grade, I believe. So, for now, just understand that that happens. Okay. The areas form patterns that run parallel to mid-oceanic ridges and are the same on both sides of it. Earth's magnetism flips once every 1/2 million year. The magma cools to form new crust. It keeps the magnetism pattern of the time it was formed. This caused the altering band of positive and negative rocks to form. This showed that the crust is spreading and supports the theory of continental drift. So Again, it just says that, when the rocks expand and cools, it has certain kind of, magnetic effect, and the altering positive and negativity on the rock to form the expansion. This shows that the crust is spreading and supports the theory of continental drift. Now, if you see here, this is a magma. This is a molten rock which is coming through the space out into the air. And here underwater mountains. These are the underwater mountains, and these are the mid-oceanic ridges, and that is a continental shelf. Okay. How do scientists explain Earth's features? The theory of continental drift was integral to understanding how and why the ocean floor spread, but it cannot explain other features of the Earth's crust. Plate tectonic explanation. Scientists use theory of plate tectonics to explain why the features of Earth look the way they do and why certain geological events happen. Earth's lithosphere is made up of about 20 moving plates. Some, such as the North American plate, are the size of continents. Others, such as Caribbean plates, are smaller. These plates float on a layer of partially melted rocks. They move in a continuous motion in different directions. The surfaces of these plates form the continent and the ocean floor. Scientists can determine the direction plates move and how they move by transmitting lasers from satellite in the space down to the Earth. For example, data indicates that North American plate and Eurasian plate are moving about 2.5 centimeters apart each year. As the plates shift, continents may separate or move closer to one another depending on the direction of the movement. When magma rises to the surface through gap in the plates, volcanoes may form. Mountain chains can also develop when plates move together or on the dry lands, or when they move together in the ocean. Scientists are able to predict what Earth may look like millions of years into the future. There is evidence that continental drift takes place at the same rate, and scientists predict that the plates will continue to move at that rate. Currently, plates movement is making the Atlantic Ocean larger, Pacific Ocean smaller, and the Himalaya mountains higher. Let's see the map. So here we are. The Atlantic Ocean will be larger than it is today. So the Atlantic Ocean will be larger. Africa will move away from Europe. So Africa is slowly going to drift, and it may move away from Europe. A large break will form through the East Africa. So there will be a break through East Africa. So that's where the line is. This is all their calculations, and then this is what they're predicting in future. Australia will move northwards towards East Asia. So Australia is slowly drifting towards East Asia, and the Pacific Ocean will be smaller than it is today. So Pacific Ocean might be smaller than today. Let's see what North America and South America will happen. North and South America will separate. So the North and South will completely, as of now it is connected, but North and South America will be separated. So that is what it is in future, according to their calculations and predictions. Now, plate boundaries. So we have divergent plate boundaries and convergent plate boundaries. So what is a convergent plate boundary? Convergent plate boundaries occur when plates are recycled back into the Earth's mantle. So convergent plate boundaries, when plates are recycled back into the Earth's mantle, rock layers in these areas will fold. So as you see here, this folding, these rock layers are folding, and volcanoes and earthquakes may occur. So what happens in these areas where they're getting converged and then the plates are recycled? What is happening there? It can have a subduction. This is called a subduction when it slides down, a subduction. And then here, what's happening? What can result? It can result into volcano, or it can result into earthquake. Convergent plate boundaries can also double the normal thickness of the continental crust. So because they are having things from other the other plates are coming in, the convergent plate boundaries will always be a little bit stronger. Okay, so convergent plate boundaries can be doubled than the normal thickness of the continental crust, creating mountain ridges and plateaus. The Himalayas and the Andes mountain ranges were both formed when plates converged. So the Himalayas was formed when plates converged together, and the Andes also in the same way. What is a fault? A fault is a crack in the Earth's crust where there has been rock movement on either side. So whenever you see a fault, just a crack between the Earth's crust. So, and it's an opening kind of a thing. That's how you have to understand opening. Okay. Now, San Andres fault is it's a fault. What is a fault again? It's a small crack in the Earth's crust. And this is in California area. A crack or a fault occurs in Earth's crust when plates slide past each other. So how does it happen? When two plates slide past each other, they, the friction between them causes a crack. Okay. So again, we have a convergent plate boundary and a transform plate boundary. What is a convergent plate boundary? Occurs when plates are recycled back into the Earth's mantle. Okay, convergent plate boundaries can be doubled, it becomes more thicker, creating mountain ranges and plateaus. The Himalayas and Andes mountain ranges were both formed when plates converged. Okay, or convergent boundaries. Now, what is a transform boundary? Transform boundaries or transform fault systems occur when two plates slide past each other. The transform faults may divide the center of the ocean ridge that are spreading or may create stiff cliffs or mountains under the seas. The San Andres fault is in California is another example of a transform fault boundary. So all three types of plate movements may cause earthquakes, although the frequency and the magnitude are not the same in all areas. Volcanic activity usually occur along the convergent or the divergent plate boundaries. Okay, so we have convergent plate boundary, we have divergent plate boundary, and we have the transform plate boundaries. Okay. The causes of earthquakes and volcanoes. Earthquakes, tectonic plates move so slowly that you cannot feel or see the movement. That's true. We never figure out when volcano is going to come or when the earthquake is going to come until and unless it happens, right? Some plates may also stop moving if edges of the lithosphere get caught against each other. The earthquake happens when this energy and the pressure builds up and eventually release suddenly, shaking the earth. During an earthquake, the rapid movement of the rocks transmit energy through the Earth's crust in the form of waves. There are several types of waves that travel above and below the surface of the Earth. Primary wave, also called as the P wave, and the secondary wave, also called as the S wave, are the body waves that travel below the Earth's surface. Again, remember the P wave and the S wave that travel below the Earth's surface. P wave move the ground back and forth and are the fastest type of waves. So these pointers you need to know. Again, during earthquake, there's a rapid movement of rocks that transmit energy through the Earth's crust, okay, in the form of waves. There are several types of waves. However, there are P waves, S waves. And what are P waves? P waves just indicate they are the primary waves. S indicates secondary waves, and they both travel to the Earth's surface. P wave move the ground back and forth. So what does a P wave do? It moves the ground back and forth and are the fastest waves. S wave moves the ground up and down. So that's the difference between the P wave and the S wave. P wave moves the ground back and forth. S wave moves the ground up and down or in a circular motion. Okay? Waves lose energy as they spread out from the epicenter to the damage. So the damage caused by the earthquake is greater at their point of origin. So always remember that earthquake, when it happens at the point of origin, that means wherever it is happening, that is that place is called the epicenter, and the epicenter is where the maximum damage happens. Okay. Aftershock or small earthquakes that happen, excuse me, after the initial earthquake are caused by strains of rocks after the original earthquake is done. So that's quite understandable. So once the main thing is done, then there are small earthquake shocks which are not that capacity of intense damage. Okay, so the focus of the earthquake is the point within the earth along the fault where the earthquake originates. The epicenter is the place where it originates. Okay, and the epicenter is a point of the Earth's surface right above the focus. The study of earthquake is known as seismology. So that's another thing which you should know, obviously. So the study of earthquakes, that means the scientists who study the earthquakes, where is it going to happen? Where is it going to start? Is there any indication of any kind of vibration happening? So all this kind of pattern observation and recording the pattern is all done by the seismologist. Okay. So a seismologist, a person who studies about everything and anything about earthquake. Okay, and that process of studying the earthquake and recording the data and analyzing the data, they are all called, that kind of study is called seismology. Okay, and the words seismos is from the Greek word, which means shake, to shake. Okay, about 1,000 instruments known as seismographs are used around the world to detect earthquakes. About 1 million mild earthquakes are recorded each year. About 20 modern earthquakes occur each year, and major earthquakes happen once every few years. Seismologists compare measurements taken at several different locations and determine an earthquake's epicenter and magnitude. So these seismologists, they have to determine the earthquake's epicenter and what would be the magnitude. And if there is one fast approaching, how much amount of intensity, destruction will it cause, right? And for that, there is a measure that is called Richter scale. So the strength of the earthquake is measured using Richter scale, which measures the height of seismic waves, surface waves. It uses a series of numbers from 0 to 9, and each whole number on the scale represents 10-fold increase in strength. So when you learn in depth about the Richter scale, you'll come to know how to identify how intense it is. Okay, that is all about the earthquake. Again, remember, we need to remember a P wave, S wave. How does a P wave work? How does the S wave work? Again, how does a P wave work? The P wave goes back and forth and is the fastest wave. S wave goes up and down or in a circular motion. Okay. Volcano. Volcanoes form deep within the earth, usually in a upper part of the mantle. Magma or the molten rock accumulates under high temperature and pressure and eventually rises to the surface of the earth. The theory of plate tectonics can help explain why most volcanoes occur near the plate boundaries. At locations where there are convergent plate boundaries, one plate may sink beneath the other. This crust may eventually sink far enough to melt and become magma. Gases trapped in the magma causes pressure to build up, and pressure can increase to such an extent that the crust cannot hold it. This pushes magma towards the surface through volcanoes. Magma that reaches the surface is called as lava. Yeah, so lava is nothing but is a red molten liquid that is being pushed up into the opening of the volcanoes. Okay, and then once it comes out, it is magma. That's when we say magma is erupted or the lava is coming out. Magma can erupt from a single vent. A vent is an opening. Okay, vent known as volcanic vent from a cluster of vents or along one long crack or fissures in the earth's crust. Most volcanoes are found in divergent plate boundaries under the ocean and have grown to form mid-oceanic ridges. As plates move away from each other, magma rises to the surface and cools. The lava forms new crust and ridges become larger. Convergent plate boundaries or volcano. Magma rises to the surface. See here, the magma is rising to the surface. The red line arrows show the direction of movement. Magma is rising. If you look at this picture here, magma is rising. Then plates move past each other. Here, see the plates are moving past each other. They're divergent plate boundaries. Different types of volcanoes. When we think of volcanoes, most of us have a picture in mind of a cone-shaped mountain that spews lava. However, volcanoes that have formed on land have many different shapes and sizes. This is mainly based on the way the volcano erupts, the frequency of eruption, and makeup of the magma. Composite volcanoes, such as Mount Fuji in Japan, shown below, repeatedly erupts from the same vent over long periods of time. Cinder cone volcano. So one is composite volcano, the other one is cinder cone volcanoes, usually only erupt once. Shield volcanoes, however, gently sloping sides because they do not erupt with force. So again, composite volcano, there is cinder volcano, there is shield volcano. Okay, all of them have a little bit of difference in the way the lava falls or goes down. Okay, and the intensity of it too. Lava flows out of the shield volcano slowly and across large areas. Two examples of this type of lava volcano, the examples of this type of volcano are Hawaiian volcano, Mauna Loa, and Hale, Halikala. A caldera is a crater. What is a caldera? Caldera is a crater that forms after the ground collapses because of the explosion eruptions. To be considered a caldera, a volcanoid crater must at least have a kilometer wide. A crater must be at least a kilometer wide, but some are over 30 kilometers wide. Yellowstone National Park in Wyoming have several examples of calderas. Really? Volcanic plateaus may also form on lands where lava flows out of the fissure vents. These plateaus can cover thousands of square kilometers. So here, this is how a caldera volcano looks. Composite volcano looks like this. It has a steep conical shape. Caldera does not have a steep conical shape. Ash cinder volcano has a nice good vent. Shield volcano's vent is almost down. So if you want to identify the different types of volcanoes, this is how it is. We have ash cinder volcano, shield volcano, caldera volcano, and composite volcano. With this, I think we are done with pretty much our types of volcanoes. We are done with the causes of earthquake and volcanoes. We are also done with different types of boundaries, divergent, convergent, and transform boundaries. Okay, so I'm putting this and I'm reading all this out to you so that you can, hear and listen and also understand by looking at the pictures. And please make sure that you take notes of all this, put the notes in pointers so that you have an understanding of clearly as to what to learn and how to learn, and all the important or new words, new vocabulary highlighted in the color that you like, color coded. If there is a definition that you need to remember and you're not getting it color coded in a different way, make sure that your notes, your note taking skills are good, and that way you will always, you'll always never find anything to be difficult, because you already listened to the video, you have revised it multiple times, you have now have all the definitions for the new terms that you learned, and also how to take the notes. So with all that, I am 100% sure that you will always be successful in what you do. Okay, thank you guys for listening, and if you like it, please like my videos. Thank you.